Have you ever wondered how the absolute deepest, most abstract concepts in math actually weave the physical fabric of our reality? Well, let's dive right into this explainer. We're going to trace a strikingly simple, elegant mathematical rule all the way up to the foundational physics of a self-simulating universe. We're talking about how a basic symmetry literally cascades into the ultimate nature of space, time, and matter. It's going to be a fascinating ride.
So here's our roadmap. We'll start with the power of duality, then look at points, lines, and graphs, before expanding into space, time, and objects, and finally capping it all off with triality and the universe.
All right, Section 1, the power of duality, the symmetric switch that literally changes everything.
Think of duality as a perfect mirror. It's a symmetric relation where if you dualize proposition A, you get proposition B, and if you dualize B, you get A right back. This isn't just some niche idea either. This symmetric relation pops up absolutely everywhere, from the fundamental rules of logic all the way to the theory of categories, geometry, and analysis. Essentially, there's this hidden underlying two-way street in mathematics. Flipping a concept doesn't break it. Instead, it reveals an equally true reflection of the same idea.
Let's move on to Section 2, points, lines, and graphs, where we can really start visualizing this flip.
Take standard projective geometry, for example. We know that two non-coincident points determine a line, right? But what if we hold up that mirror and just switch the terms? Suddenly, two non-parallel lines determine a point. This is a brilliant, totally clear illustration of the duality operation. Just by swapping the words point and line, the core geometric truth stays perfectly symmetric. You can even restate this as points are functions of lines, which dualizes perfectly to lines are functions of points. It completely exposes a foundational duality between functions and their arguments.
And that exact same flip applies straight to vector algebra. Think about vector space V. Its dual space, which we call V star, is the space of all linear functionals on V, basically all the linear maps from V to real numbers. Now dualize it again, and you get V double star, which is the space of all linear maps from V star to real numbers. It's that exact same functional mirror we just talked about, but scaled way up into complex algebraic spaces.
We can actually push this even further, right into graph theory. Picture a planar graph in your mind. First, we'll transform its faces into vertices and its vertices into faces. Then, we replace the boundary of each face with transverse edges that converge on its dual vertex. Finally, we just redefine the adjacency relation. What are we doing here? We're essentially turning the entire structure completely inside out. We're inverting it, but, and here is the crucial part, without disrupting its overall pattern of adjacencies. It's honestly like a geometric magic trick.
But wait, what happens when we throw time into the mix? When the edges in our graph are given a temporal interpretation, some truly incredible transformations kick in. Circulations along facial boundaries suddenly morph into vertex spins. Motion along an edge becomes an actual operation between the dual faces of its endpoints. Just by injecting time, this static geometry suddenly wakes up and becomes a dynamic, interacting process.
Okay, Section 3, space, time, and objects. Now we're really expanding the dimensions.
So, when we look at physical reality, there are two common varieties of duality principles at play. First, there's space-object, or SO duality, which simply transposes spatial relations and physical objects. Second is time-space, or TS/O duality, which transposes objects or spatial relations with mappings, functions, operations, or processes. The essential feature to grasp here is that we're swapping an element with a spatial or temporal relation of elements. We are literally swapping the players with the field.
And that brings us to Section 4, triality and the universe, the ultimate simulation. By adding our SO and TSO dualities together, we arrive at something much, much grander, triality. This represents the universal possibility of consistently permuting the fundamental attributes of time, space, and object. Think about it. We're no longer just swapping two things back and forth. We now have a consistent three-way permutation mapping the absolute core attributes of reality itself.
From this triality, we can extract a third kind of duality, STO, or conspansive duality. In this mind-bending framework, physical objects themselves are dualized into spatial-temporal transducers. The very things we consider to be solid, static matter become active processors of space and time. This profound flip forms the partial basis for highly complex theoretical models, including structural concepts like homology and the M equals R mapping universe.
Because objects act as these spatio-temporal transducers, we arrive at a genuinely staggering conclusion. We get a model of the physical universe that is internally simulated by its material contents. Meaning, the universe isn't just some big empty box containing stuff. The material contents themselves are actively generating and simulating the universe from the inside out, all driven by this mathematical duality.
So after tracing simple points and lines all the way up through functional spaces, temporal edges, and triality, we really have to wonder about our own place in all of this. If the physical universe is internally simulated by its material contents, well, are you just a spatio-temporal transducer in a self-simulating universe? It absolutely changes how you look at the space around you, doesn't it? Definitely something to chew on until our next explainer. Keep questioning the geometry of your reality.